All right, today we are talking about transformations. So we're going to take an equation and be able to change something to it, and we're going to transform it to graph or what the graph looks like. So all this may seem like a little bit of gibberish, but how you're going to see it today, you might see it with a y equals, right? Y equals, and then you're going to definitely see function notation. Okay. Now I've left some space because I know what this is going to look like. Um, and I'm going to try to color code this as well as I can. Okay. So um, it's going to be in function notation. So you're going to see this F in there, the F of X. And then what you're going to see as well are other values attached to this function. Okay. And so we need to talk about those values. The first value is represented by the letter A. Okay. And so this A is just going to be a number in front of F. So that's where it's going to lead with. So that first number is always going to be um, considered A. Okay. Now let's talk about what A can be. A can be one of three things. Okay. And so this is where I want you guys to come and fill this out. A can be greater than one. Okay, so a lot of times, it's easy. It sounds right when we say A is greater than one. But what I highlighted there is actually the mathematical way to write A is equal to one. So what happens when A is equal to one? We have what we call a vertical stretch. Oh, stretch. And do that. There we go. By factor of A. Okay, so for instance, if I went to Desmos, let's see here. What might that look like? Let's say f of x is equal to x, right? Well, now so I just defined a graph. So this is my f of x graph. Now I can say y equals, let's change the a value to 2. Okay, and you can see now what happened. So now it got a little bit steeper. That's what we call a vertical stretch. Okay, and I can change, obviously what I change the function, but here it's just a line. So for instance, if I change that to the absolute value of x, then we can kind of see that it's been vertically stretched. So it's gotten stretched thin and narrower. Okay, so that's anytime this number is greater than one. It gets what we call a vertical stretch. Okay, so that's the first thing that can happen. The second thing that can happen is this can also be a number between 0 and 1. So that's how you write mathematically that A is between 0 and 1. So when we have a number that is between 0 and 1, we call that a vertical compression, okay, by factor of A. Okay, now what does that mean? That means I'm going to take that same number, okay, that same number in the front, and this is going to be a number between 0 and 1, so like 1/2. Okay, and you can see what happened to the blue line. Now we compressed it vertically, so it theoretically got shorter and wider. Okay, another thing is 1/4. Okay, 1/5 is between 0 and 1. 0.25, right? 0.9. So again, that number in front, that A value is between 0 and 1. Okay, and so that's what we write it out as. All right, and then the third thing that A can do is back right here. Okay, now it's on number 6, so it says y equals negative f of x. Okay, so we still consider that part of the A value. So if there's a negative at the very front, it is a reflection over the x-axis. Okay, that's important. Reflection over the x-axis. So again, if I come to Desmos and I change that A value, if I just put a negative in front, now that's a reflection. So the blue line is a reflection over the x-axis. Okay, so we have to know that it's a reflection over the x-axis. And so those are the three things that this first number does, this A value. Okay. And then the second thing I'm going to look at, I'm going to skip what the B value does, and we'll come back to the end. That's just kind of icing on the cake. A, C, and D are things that we have to know. Okay. So next letter, let's do that in purple, is going to be C. So C is right here. Usually in the equation, it's going to say X minus C. I'm going to actually put a plus or minus there. So what happens when we have each, right? So I can either add C to this X variable inside the parentheses. So it's inside parentheses, or I can subtract C inside this parentheses. Okay. So what are those effects, right? If I have, and again, I'm just going to write out the parentheses right here. If I have X plus C, so I've added C inside the parentheses, then this shifts to the left. Okay, so the C value inside those parentheses, it kind of does opposite of what you think it's going to do. And so then if I have X minus C, then this is going to shift to the right. Okay, by C units, right? So let's go and check this out again. So here's my absolute value. If I again add a number, let's take that off. If I add, let's say 5, well, now you see that from the red to the blue, it just shifted over 5 units. Okay, and so, I can change that number, but as long as it's plus, it's going left. Okay, and then on the contrary, if I subtract, then now it's going to the right by that many units, right? If I subtract 7, it will shift it to the right 7 units. Okay. And then the next one is the D value. Do that one in pink. So again, this is plus or minus D out here. So this is the last number outside of parentheses. So if there's a number outside of parentheses. So if I add D, then we shift up. If I subtract D, we shift down. So again, just to prove my point, this time we don't have a number inside the parentheses, we have one outside. If I add, right, add 1, it starts shifting up. Add 2, 3, 4, right, and it shifts up by that many units. Okay, if I subtract, it goes down that many units. Okay, and so that's stuff that we have to know. Okay, these are the most common transformations that you'll see out of A, C, and D. Okay, and again, these are just representing numbers or values. Okay, so let's talk about this B value. So the B sits inside the parentheses. Okay, but it's in front of the X. Okay, and so this one is probably the most confusing, but it's like A in a sense, except everything's horizontal. Okay, so again, same concept. We can have B greater than 1, well, this is going to be a horizontal compression by a factor of 1 divided by B. Okay, so that's what makes this kind of tricky, right? So what do I mean by that? So now B sits right here in front of this X. If I say B is greater than 1, okay, like it's a 2, right? It kind of looks like it did when we did the vertical stretch, but we have to understand in our brain that that B is a horizontal compression. So we're squishing it together sideways, so it's getting narrower and or thinner than the original graph, right? And the bigger that number gets, the narrower it becomes, right? Okay, and so when we say that, let's say we use this 9, I would say, hey, this is a horizontal compression by a factor of 1 divided by 9. Okay, and so that's what's kind of confusing here. That's why I said by a factor of 1 divided by B. So whatever that B value is, I just divide. Okay, and so then what happens if I have a number that's between 0 and 1? Well, this is considered a horizontal stretch, okay, by factor of, again, 1 divided by B. Okay, so let's go back and change this now. So now this number is 1/2. Again, looks very similar to a vertical compression, but again, we know that it's a horizontal stretch, and so it's gotten wider this time. Okay, and again, the lower that fraction gets, the wider it is, right? And so then this again is the tricky part. Let's say our factor is 1/4. Well, I would say it's a horizontal stretch by a factor of 1 divided by 1/4 is just a factor of 4. I just flip it. It just becomes a reciprocal, okay? And then number 5 has a negative in front of the B. And so if B is negative, right, if B is negative, then it's a reflection over the y-axis. And you have to know the difference. You can't just say reflection. You got to say reflection over the y-axis. Okay, and so for this one, it's going to look unchanged, or it should look unchanged. Okay, so there's my red one. I just toggle off the blue, and then there's my blue one. So it looks the exact same because it's a reflection over the y-axis. Okay, and so this is symmetric about the y-axis, so that's why it looks the exact same, right? But if I were to, let's say if I were to, let's do subtract the 2 here, well, now we can kind of see, like, this is my original in the red. If I reflect it over the y-axis, now my vertex was at 2, now it's at -2. Okay, so maybe that helps just a little bit.